Here we go with 7.1. We're talking about monomials and polynomials. Um, there's going to be a little bit differences in what we can do with them when we're talking about being able to add, subtract, multiply, divide, things like that, things we normally do in a math class. So let's start with monomials. A monomial means you just have essentially no addition, no subtraction, nothing like that. You have a term. Think of it that way. Something we've talked about before is a term. You have a number, you have a variable, and you have a combination of a number and a variable or multiple variables. And we'll get into that in just a second. All of that means you have a monomial. You're not adding or subtracting anything. You just have products. That's a monomial. We have a definition written on here, but that's another way to be able to say it is we don't have addition, we don't have subtraction, we don't have additional terms. I just have one term, and that term is referred to as a monomial. Now, to know what degree that monomial is a little bit different. What we have to do is we have to add the terms of our variables. I almost said exponents, but our variables. So what we're looking at here is this is 5 to the first and x to the second. If I was adding the variable the exponents of all parts, my number and my my variable, then my power or degree would be the third degree, but it's not. All we're actually looking at is any variable, and then we're going to add the powers for all variables I find. So I need to look at this x to the second and recognize that that is a 2. And so the degree of 5x squared is the second degree. And I apologize for my nose. It is clogged. All right, so down here, I need to see that there is x, and I need to recognize that there is y to the third. So I have x to the first. Remember, if there's not an exponent written, it is an exponent of 1. And we have y to the third. So what I need to look at to be able to answer what degree is this monomial is I need to look at the 1 and the 3 and add those two together. So this is going to be 1 plus 3 is 4th degree. This is a 4th degree monomial. Now we're going to be able to do the same thing down here and recognize that here's x to the third. Here is y to the third. So when I rewrite those, and I forget about the 8. To be able to find the degree, I'm forgetting about that coefficient. I don't care when I'm just trying to decide to what degree monomial am I dealing with. So I'm going to look at this 3 here. I'm going to look at this 3, and I'm going to say that's 3 plus 3 equals 6. So this is a 6th degree monomial. Now, D could be interesting if you don't really think about it. See, this could be x to the 0, because anything to the 0 is 1, and 1 times anything is itself, so the negative 3 could be written as x to the 0, which means I'm the 0 degree. But underneath that same logic, what if I said y to the 0? Great question. If I had y to the 0 and x to the 0 here, that means I would have x to the 0, y to the 0. I'd be looking at these zeros. So this becomes 0 plus 0, and that means this is to the 0 degree monomial. So no matter how many variables I choose, the exponent would always be 0, causing it to be 1 as a complete, because anything to the 0 is 1. And then I'd always be multiplying by 1 until I had that original number I started with, in this case, negative 3. I throw out the negative 3 when I'm talking about the degree of the monomial. and I only look at the powers, they're all 0, add them all up, 0 plus 0 plus 0 plus, and any amount of zeros you want, it's going to be 0.